All right, guys, let's talk about force vectors in this video. A couple things you'll need before we start. You're going to want your notebook and a pen or pencil to do a little writing and some math with me. You are going to want a calculator that's not your phone, especially one that has sine, cosine, and tangent on it. If you have a fancy schmancy calculator, make sure the mode is set into degrees and not radians. You can use your phone if you, with your iPhone, if you turn it sideways, it turns into a scientific calculator. It might be a little bit awkward. If you have a kind of a normal calculator, I would recommend it. I am going to cover all of these things in red, and if you just follow along, you'll be all done for what is part one for force vectors. Okay, let's jump right in. First of all, let's talk about the difference between scalar and vector. One other thing before I forget, I always do these videos keeping in mind that you guys are going to pause as you need to. You shouldn't be writing as fast as I'm talking, so pause as you need to, and then jump back in when you're all set. So scalar is magnitude only, for example, like 60 miles an hour or 150 pounds. Notice there's no direction, it's just magnitude. That's very different from a vector quantity, which is magnitude and direction. 60 miles an hour northwest, or the car was traveling 60 miles an hour south. So scalar versus vector quantity. With vectors, the way we our notation for vector quantity, we always draw a little arrow above the vector's name. So this would be vector A, and its magnitude would be 3 newtons in this case. If you're not familiar with our symbol for theta, that just shows our angle. We often see this as angle, and then angle equals 30 degrees. All right. Some of you, I'm very aware this is a review. Some of you, I know it might be new, so I'm going to treat it as such. Sine, cosine, and tangent are basically ratios of a right triangle. All the things that I'm about to cover, you can only do with a right triangle. So sine of theta, and remember theta is our angle, sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. If you haven't heard the mnemonic SOHCAHTOA, so that's how we remember it. So S, O, and H, C, A, and H, and then T, O, and A, SOHCAHTOA. That's how we remember those equations. You're going to be using them quite a bit in this unit. Make sure you're familiar with these. Here's a little check for your calculator. Go ahead and do sine 37 times 12. Everybody's calculator is different or phone is different, but if you're doing that correctly, you should get 7.22. A couple tips, again, it depends on your calculator. On the blue ones like we use in class, we have to do sine and then the angle in the parentheses and then multiply that times 12. Again, yours might be a little different, but make sure you get, however you do it, make sure you get 7.22. Okay, let's draw our first example. Let's draw this scenario. So we have vector A, and it is 75 newtons, and it is 35 degrees from the horizontal. Let's do a little refresher on the sides of a triangle. This kind of looks like an eyeball, so I always think of that as the eyeball. Excuse me.
Alan Ferguson, please come to the office.
Sorry about that. I always think of this as the eyeball always sees to the opposite side. So that's our opposite side. The side next to the angle is adjacent, and then of course the long side of the triangle is our hypotenuse. So what we're getting at here is this is some force at some angle, but some of it is in the x direction and some of it is in the y direction. That's why we're trying to find these adjacent and opposite sides. Really important in things like bridges, right? Like our balsa wood bridges in class. So I just randomly picked sine first. You can do sine or cosine first. Write my equation and substitute my values that I know. Here's my angle of 35 degrees. I don't know my opposite side, but I know my hypotenuse is 75. And we can pretend sine 35 is divided by 1, and that kind of helps us see that we can cross multiply. So opposite times 1 is opposite, and then sine 35 times 75, you should get 43.018. Please make sure you're doing this in your calculator, not just copying my answers, because you're going to have some practice coming up. Okay, same picture. And now let's do cosine to solve for the adjacent side. Same thing, just different equation. We're going to fill in what we know. We're going to cross multiply, and we should end up with 61.436. Notice my math is from left to right, top down, nice and neat. I can see my answer. I can see my work. Expect yours to be the same. Okay, let's do our a little longer scenario. I'm going to add another piece to the puzzle. Go ahead and draw this picture. What we're looking at is a hook with two force vectors. So notice vector C at 360 degrees, vector D at 400 newtons and 30 degrees. And what I want you to do is find the adjacent and opposite sides for both triangles. So you're going to find, you use sine and cosine on this triangle to find the adjacent and opposite, and then use sine and cosine on this triangle, the 30 and the 400, to find the adjacent and opposite. Go ahead and do that and come back, and I'm going to show you the work in the next slide, but make sure you guys are getting confident at doing this on your own. So you'll go through that math, and you will get these four answers for opposite and adjacent, and then again, opposite and adjacent. Something I want you to take note of is this 200 is going to end up being negative. I don't mean the answer is negative. I'll actually show you more in the next slide. So here are those same four answers from the previous slide. Our 150, that was a positive value, so we know that that's going to be to the right. This I think it's 259, not point. Let me delete that. This 259. There we go. Anyway, that 259, that is in the up direction. And then our 346, and then our 200. Here's what I'm getting at. So this force vector, this 300, it's pulling up and to the right. So I know that the x component, remember x goes left and right, is of course going to go to the right. And the y component, my choices on y are either up or down. Since this is going up and to the right, my x is going to go to the right, and my y is going to go up. That one's easy. This bottom one is mostly easy as well. Notice this vector is going down and to the right. So my x component, this blue arrow right here, it's going to go to the right. That's positive. But this one, down. So anytime I have a negative, or excuse me, I have a vector going down or any y direction going down, as we know from your other math classes, that's going to be a negative. So that's why this is a negative 200. That's going to be important in a minute. If this red arrow happened to be going to the left, like if the vector was out up here, like up and left, it would be negative. Same with this blue one. So left is negative, down is negative, up is positive, right is positive. So that's why this guy ended up being negative. That's really important. So we're going to take these four numbers, notice our x values and our y values, we're going to add them together. So you should remember our symbol sigma. So sum of our forces in the x direction. Here's my 150 and my 346. See? Here's my 150 and 346. These are both my x's. I'm going to add those, and then I'm going to add my y's. So I add these up. I get 496.41. Notice this is x, so left or right. It's positive, so it's going right. This one with all the crazy arrows, it's really important. A positive 259 plus a negative 200 gets 50. That gets us 59. This is a y force. my choices are up or down. Since this came back positive, then I am going up. This is really important because we're about to draw a brand new picture. The whole point of this hook problem, we are trying to find, let me back up, and I probably should have said that a little earlier. The whole point of this is we're trying to find what is the resulting force and what is the resulting angle of these two separate vectors. So the vector at 300, the vector at 400, 60 degrees, 30 degrees, what is the resulting force and the resulting angle? And we're just about there. So we added our x's and our y's to get 496 and 59. We know this is right and this is up, and that leads us to draw this next picture. Now, I have the math done on this one, but I want you to just look at this red part for now. So we said 496 to the right, so I'm going to draw a big long arrow because that's a pretty big number, 496 to the right, and then 59, that's much smaller. Usually our vector arrows or vector symbols, we try and, that's still not quite to scale, of course, but a smaller number should mean a smaller arrow is what I'm getting at. So 496 to the right, 59 up, and that's what led me to draw these two red arrows. Side note, we always draw vectors tip to tail. So the tip of this vector meets the tail of this 59 vector. So we have those two. Now we need to find this blue, we need to find the hypotenuse side. That's our resultant magnitude of those two separate ones. Well, I hope you're thinking, if I know two sides of a right triangle, I can find the third, and that's just Pythagorean's theorem. So a squared plus b squared equals c squared. You can look through my math here, and you'll see you actually get 499. I just rounded up to 500. So that's easy enough. And then the very last thing, and we're all done, we need to find the angle. So it's not really tricky, but this is maybe something you guys haven't done before. Inverse any function. I happen to pick on tangent. I could use sine or cosine or tangent, because at this point, I know all three sides. I'm just happen to pick on tangent. Tangent usually gets left out. So my equation for tangent theta equals opposite over adjacent. And what we're going to do is use the inverse. It's kind of like, I don't know, if you divide both sides by tangent, you kind of think of it that way. That's not really probably the correct way to say that, but we'll run with that. Imagine if I divide this side by tangent, it cancels, so I'm just left with theta. That's what I'm trying to explain to you. And then what we're left with is called inverse tangent. And the way you draw that or write that is tan and a little -1. And then the rest of our equation is the same. So theta equals inverse tangent of opposite over adjacent. And notice that's in parentheses. And that's how you're going to do it in your calculator. On these calculators, you'll just click or hit the second button, and then you'll hit tangent, and you'll see exactly this, inverse tangent and an open parentheses, and then you just do 59 divided by 496. And what you end up is about 6.7 degrees. So that was the whole point of the hook problem, is to find the resultant magnitude, 500, and the resultant angle, 6.7 degrees.